Let's take a look at section 5.7, dividing polynomials. We want to do this in a similar fashion to what we've done already on the section on negative exponents and scientific notation. We actually have done this, and that's where we group the coefficients and group like basis into individual quotients. Then we divide the quotients and apply the quotient rule for exponents. So here's an example of that, where we divide 32x to the 7th by 4x cubed. So we are grouping the 32 and the divided by 4 and x to the 7th divided by x third. 32 divided by 4 is 8. X to the 7th divided by x to the third, when we apply the quotient rule, gives us x to the 7 minus 3. So this simplifies to 8x to the 4th. So let's practice this on 2a, b, and c. So let's divide the monomials. So in our first example, we're going to divide 55 by 11. And that'll be multiplied by x to the 9th divided by x to the 7th. And that'll be multiplied by y to the 6th divided by y to the 8th. Now 55 divided by 11 is 5. X to the 9th divided by x to the 7th is x to the 9 minus 7. Y to the 6th divided by y to the 8th is y to the 6 minus 8. So we get 5x squared y to the negative 2. We don't want to leave negative exponents in a final answer. So remember that y to the negative 2 is 1 over y squared. That's the rule for negative exponents. So this is, so 5x squared times 1 is just 5x squared. And then I have this denominator of y squared. So this is my final answer. 5x squared over y squared. All right, so let's try this for the next problem. We're going to do the same thing. We're going to work with the we're going to write a quotient for the coefficients. We're going to multiply that by a quotient for each of the like bases. All right, now 26 divided by 39 is going to remain a fraction, but we want all fractions to be reduced. We want to divide the numerator and denominator by the largest common factor, or greatest common factor, that divides evenly into both. And that would be 13 in this case. So we'll reduce that in our next step. Here we're just showing what we're going to do. and we're going to apply the quotient rule. So x is going to be raised to the 9 minus 7 power. Y is going to be raised to the 5 minus 8 power. So when we reduce 26 over 13, we actually get 2/3. X to the 9 minus 7 is x squared. Y to the 5 minus 8 is y to the negative 3. So this is equal to 2/3. And in the numerator we have x squared. And if we bring y to the negative third into the denominator, the exponent changes sign. So our final answer is 2x squared over 3y cubed. And I just want to point out that final answers should have every base appearing once. All grouping symbols should be removed. No power should be raised to powers. And no exponent should be 0 or negative. And notice in both of these answers we fulfill that. All right, so let's look at number 2C. And our work here is going to be similar. We have a negative 15 that's going to get divided by 10, and we want to reduce that fraction. So the largest number that divides evenly into 15 and 10 is 5. So we're going to divide numerator and denominator by 5 to reduce that fraction to its lowest terms. And then we're going to multiply by u to the 9th over u cubed. Times v to the 6th over v to the 4th times w to the 7th over w to the 7th. So this gives you, this is equal to negative 3 over 2 times u to the 9 minus 3, v to the 6 minus 4, w to the 7 minus 7. So this is negative 3 u to the 6 v squared w to the 0 over 2. And remember that w to the 0 is equal to 1. So we'll use that fact. We don't want to have 0 exponents in our final answer. So minus 3u to the 6 v squared over 2 is my final answer. All right, so we want to talk about, so we just looked at dividing a monomial by a monomial. The next step is for us to look at dividing polynomials by monomials. So to divide a polynomial by a monomial, we're going to divide each term of the polynomial by the monomial, and we're going to simplify using the method for dividing monomials. So what we essentially do is turn this into several problems like the ones we just worked. So if I want to divide 12x cubed minus 28x squared by 4x squared, then I do that by dividing the 4x squared into 12x cubed using the methods we just used on the previous 3 problems, and then subtracting from that 28x squared divided by 4x squared. And again, using the methods of dividing monomials. I simplify, and then I make sure I leave my final answer in an accepted simplified form. No grouping symbols, no negative or zero exponents, no base appearing twice, no powers raised to powers. So those are the things I want to make sure are true for my final answer. So let's look at a couple of examples of this. Let's divide negative 25x to the 10th y to the 7th plus 75x to the 9th y to the 4th by negative 5x to the 7th y cubed. So what I'm going to do here is I'm going to divide each term in the numerator polynomial by the denominator polynomial, which happens to be a monomial. This method only works if you're dividing by a monomial. So then I'm going to divide 75x to the 9th y to the 4th by negative 5x to the 7th y cubed. And negative 25 divided by negative 5 is a positive 5. X to the 10th divided by x to the 7th is x to the 10 minus 7. Y to the 7th divided by y cubed is y to the 7 minus 3. 75 divided by negative 5 is negative 15. X to the 9th divided by x to the 7th is x to the 9 minus 7. Y to the 4th divided by y cubed is y to the 4 minus 3. And my result is 5x cubed y to the 4th minus 15x squared y. Y to the 1st is simply y. And that is my final answer. So let's take and apply this same process to number 5. So I'm dividing negative 24a cubed by 4a squared. I'm going to add to that 8a squared divided by 4a squared. I'm going to subtract from that 12a divided by 4a squared. From that I'll subtract 20 divided by 4a squared. And I just want to point out here that the coefficients, if I don't have even division, as we did in the earlier examples on the first page of this handout, we want to make sure that we reduce fractions if the division of the coefficients doesn't result in integers. In this case, every coefficient is evenly divided by 4. So negative 24 divided by 4 is negative 6. A will be raised to the 3 minus 2 power. 8 divided by 4 is 2. A will be raised to the 2 minus 2 power. Minus 12 divided by 4 is 3. A will be raised to the 1 minus 2 power. Minus 20 divided by 4, which is 5. And we'll leave that a squared in the denominator because we know we don't want any negative or 0 exponents. So I have 6a, negative 6a, plus 2a to the 0, which will just be 2, minus 3a to the negative 1. Remember, a to the 0 is 1. Here, I get so I write 3a to the negative 1 as minus 3 over a. Remembering that the negative 1 exponent only applies to the a. Here the 0 exponent only applies to the a, not to the 2, but just to the a. And then finally, I have negative 5 over a squared. And this is the final answer. And so this is what we cover in Math 70 on polynomial division. In Math 80, you'll go a little further with this concept.